Welcome to the lecture series of Digital Communication EC 502. I, Amish Kumar, Assistant Professor, Department of Electronics and Communication, Oriental College of Technology, Bhopal. Today we are going to discuss about sampling and its representation. Now let us start with discrete time sampling. The first question arises, what is discrete time sampling? Suppose we have an analog signal and we want to convert it into digital form. Then the first step of the conversion of analog signal into digital is termed as sampling, or you can relate it with saying that it is a type of transformation in which we change the continuous signal into discrete signal. Here we can see that in the graph we have a continuous signal represented as xt. This one is our xt signal, and the discrete form of that signal is represented by x of n. That means we are getting the signal xt at different instant of time. Suppose at n equal to 0, n equal to 1, n equal to 2, n equal to 3, and likewise. Okay, so at that point of time, whatever is the value of xt we are getting at x of n. Suppose at x of 0, that is n equal to 0, at this point we are getting the amplitude of xt as this. Okay, likewise at x n equal to 3, that is this one is 0, this one is 1, this one is 2, and this one is 3. At x n equal to 3 we'll get the value of xn, or amplitude of xt as this discrete value. So these are the different discrete values, x of n, which we are getting by the help of some transformation method, and this x of n is actually called the sample of continuous signal, or you can say that it is a discrete time sample of an continuous signal of a continuous signal xt, where capital T represents the sampling time periods. For t equal to n of t, here capital T represents the sampling time period. Sampling time period means the rate at which we are taking the samples, or the time at which we are taking the samples. Okay, and sampling frequency is the rate at which we are taking the sample. Sampling time is actually the time period for which we are taking our samples. Here this t equal to n of t is the different times on which we are taking our samples, or we can understand it by the help of this block diagram. Suppose we are having a continuous signal xt and passing it through a discrete time sampler, we will get x of n. This is our x of n signal. Okay, then after we pass it through a discrete time signal system and get some y of n, then we'll use a signal reconstruction constructor and again use continuous time signal xt. That means sample the continuous time signal, design the process discrete time signal, and convert it back to continuous time signal. This is basic communication method in which we convert our continuous time signal into discrete one, process it, and finally convert it into analog signal. Okay, now the question arises, how we convert this continuous time signal into discrete one? What are the mathematics associated with that? Okay, and the second question arises is how we can define normal definition. What is the normal definition of sampling? Obviously it is a transformation method of converting continuous signal into discrete signal, or you can also define it as it is a process in which we take the instantaneous value of a continuous signal. So sampling is defined as the process of measuring the instantaneous value of continuous time signal in a discrete form. Obviously means you can see that we are getting the instantaneous value at this instant. What is the value of xt? We are getting the value of xt at this instant. What is the value of xt? We are getting the value of xt, and represented it by x of n. So we can define sampling as a process of measuring the instantaneous, mind it, instantaneous value of continuous time signal in discrete form. Okay, or you can also say that in normal communication, if we are going to a market and have to buy some grains, then we are asking for the merchant, please show me sample of the grains. Then he will put some instant of the values or some piece of the values for you. They are not bringing the whole container to show you, just a piece. Okay, so sample is a piece of data. Okay, means sample is actually a piece of data taken from the whole data, taken from the whole signal. A piece of signal is taken, which is obviously continuous in time domain. Which is continuous in time domain means at that time domain it is continuous. See, we can see that for this last sample, this signal, if we will enlarge this sample, this sample is actually continuous for this small instant of time, say delta t. Okay, and actually this is the instantaneous value of our signal xt. This is our xt, and this value is represented as x of n. That means we are getting the piece of signal from the whole signal. This is the whole signal. From this whole signal we are getting a piece of value. That piece of value is sample, and the process of converting this analog continuous signal into discrete form is called sampling. Okay, the two things are very clear, that sampling is a process of converting continuous signal into discrete one. Okay, and samples are the instantaneous value which is taken from the continuous signal at any instant of time. Suppose someone say that find the value of x of 5. For this, suppose this is x of 0, this is x of 1, this is x of 2, this is x of 3, this is x of 4, and this is x of 5. That means x of 5 is this. The value of the sample at x n equal to 5 will get 0, 1, 2, 3, 4, 5. This one, this value. Okay, so this is sample, and the process of converting this continuous signal into this discrete one, this like this, is called like this, is called sampling. These values are called sampling. Okay, so we get two things. First one is the process of measuring instantaneous value of a continuous time signal in discrete form is called sampling, and sample is basically a piece of data, a piece of signal taken from the whole data or signal which is continuous in time domain. Continuous time signal, suppose this is continuous time signal, and we are taking the instantaneous value, and that piece of value is called sample. Okay, now moving towards how we convert that continuous signal, into this discrete one signal. Okay, this process is basically conversion of continuous signal into discrete one by the help of multiplying xt with impulsive train. We will multiply the signal xt with the impulsive train, will get this signal. Okay, and this signal is basically our sampled signal. For every instant of time, for every instant of this impulsive value, will get the signal. So we can see that converting a continuous time signal into discrete one, we need an impulsive train. This is an impulsive train. Okay, and what we have to do, we have to multiply the continuous signal xt with the impulsive train. Okay, and when we multiply these two signals, we will get a discrete time signal which is valid at every instant of time where the impulse train is defined. Suppose impulse train is defined at x equal to 0, that we must get some value at x equal to 0. If it is defined at x t equal to 3 suppose, so we must get the value at t equal to 3. Suppose this is t equal to 0. Okay, then every instant where the impulsive signal is defined, we get our discrete signal. We are not getting any discrete signal in between. Suppose we are not getting any discrete signal in between this. Okay, see, we are getting discrete signal at here and at here, but we are not getting any discrete signal here because impulsive train is not defined at that instant of time. Okay, so in the instant of time where impulsive signal is defined, we will get the discrete signal only that instant of time. Is it clear? Suppose we are having a continuous signal x of t, okay, small t, and what we need an impulsive signal. This is impulsive train. Okay, we need an impulsive train to get the discrete time signal or sampled version of xt. Okay, sampled version of xt is x of n. Suppose x of delta t, this x of delta t is nothing but x of n. Okay, so how we'll get it by multiplying xt with the signal pt. Okay, so we are getting x of pt or x of del t or x of n, all of them are same. That means x of n means discrete time sampled signal. Okay, discrete time sampled signal x of n or x of pt can be easily calculated by the help of multiplying xt into pt, where pt is a continuous time impulsive, it is a continuous train, basically impulsive train. It is a impulsive train. So pt is represented by this, that is a delta function which is defined at n of t, where n values lies from minus infinite to plus infinite. Will have n equal to 0. That means we are getting delta t. This one is our delta t. For n equal to 1, putting n equal to 1, we will get t equal to this one, t equal to, suppose n equal to 1, small t equal to capital T. Okay, likewise n equal to 2, we are getting t equal to, suppose n equal to 2, we are getting t equal to 2. That means 0, this one is 1, this is 2t, this is 3t, 4t, 5t, likewise minus t, minus 2t, minus 3t, minus 4t. This is the impulsive train. Okay, so just multiplying this impulsive train pt with the signal x of t will get the sampled signal. Okay, next part is basically this impulsive train, this multiplied version of impulsive train is what? This is the known as impulsive train sampling.